Our fourth speaker will talk about formal verifications of token economy models, and it's Aleksander Letychevsky.
Hello, I'm Alexander, and I will present our research on the usage of the formal methods and algebraic approach in the verification of the token economy models. So we are the team from the Garuda AI company. It's located in the Netherlands, and we cooperated with the Glushko Institute of Cybernetics and the Kherson State University. This is the team which has had 2 years experience in industrial verification and cooperate with such companies as Motorola and Intel, and we also worked with model-based testing in cybersecurity, algebraic modeling in different subject domains like telecommunication, automotive system, and this team is the followers of the great algebraic school of the Viktor Glushko, and our experience we now continue with the analysis of token economy projects. So these results were obtained after the successful implementation of the number of projects with the healthcare, skill monetization, and the file exchanging service and marketing strategy selection, and the other project where token economy properties were investigated. So the general goal was to create some approach and to create some methods to be confident that to analyze the token economy project, to be confident that it is meet the business expectation. So there are the following tasks. It's how to formulate what property we should check to be sure that the project works properly, how to formulate the token economy, tokenomic objects, how to simulate it, what math and the algebraic methods shall be used for the simulation and proving of this property. So we propose an algebraic approach in tokenomic modeling implemented within the scope of insertion modeling methodology that focuses on the building of model and studying the interaction of agents and environment in a complex distributed multi-agent system. So this is the example of the agents in the Skillonomy project. There are the 7 types of agents. So we have the main agent. It's platform or some kind of platform owner. He created the platform for skill education, online skill and education, and sell the nodes. And nodes owner provide the education service to the students that perform skill mining. They pay for the education and obtain an award for the successful education. There are good student, best student, excellent student, different kind of students. Too many agents in market the typed or the type students. There are other agents that are interactive, the coaches and managers, which nodes owner were hired by nodes owners. Also, the agents perform different actions. They sell, buy token. There's a token in the system. They invest money, invest token, get revenue, pay fee. Every agent has characterized the type is defined by some set of the typed attributes. These are the set of the attributes of different type: real, symbolic, integer, enumerated. Behavior algebra, it is the mathematical some mathematical methods for the description and of the behavior of the object of the agent, and this behavior algebra we used in the scope of the insertion modeling technology. So it was introduced in 1997 by the British scientist David Gilbert and Letychevsky the senior. It is double sorted algebra and is defined on the set of the behaviors and actions, and it defines the operation over these objects. There are the prefixing and the non-deterministic choice, also the number of terminal constants, and the approximation relation. So we can define the behavior of the sum agent as the system of equalities. Also, behavioral algebra has two operations over the behavior: is a parallel composition and sequential composition. So this is an example of the creation of token of the behavior of the agent in the token economy project Skillonomy. So you can see in the right side the system of the equalities. So it is presented in a recursive manner. So the main equality, the B, and it is unfolded in other actions and equality. We see the action next month, and then behavior B0, and after that behavior B, and they unfolded another behavior. In the left side you can see the mapping of the algebra to the standard requirement language UCM, use case maps. It is easy to visualize. It's good to visualize the algebra expression into this graphical construction. You can see the action. They mark it at the cross on the graph, and as a rhombus, it's the behavior which should be unfolded in another graph. Action also has its semantic. It's semantic defined by the triple, the precondition, postcondition, and the process. Precondition and postcondition, there are the formulas in some basic logic language. For token economy analysis, is enough to consider the set of formulas of the first order logic of a polynomial arithmetic. And the process component is component for visualization of the scenario of the token economy. So all the semantic of the action is the following: the action is applicable if the precondition is true for concrete case, and the precondition is satisfiable for symbolic case. So what can we do in the scope of the behavioral algebra? First, so when we have the project created of such manner, we can do everything, use all results that we have in behavioral algebra. It's very powerful mathematical, very powerful mathematics. We can use algorithm, theorem, and method that are very developing in the scope of the model checking and formal verification techniques. So we can prove also this is all can be implemented in the scope of insertion modeling system, which can prove using the its own and the external tools like Microsoft S3 Prover and CVC and other proving and solving system. So we can prove the statements over the agent's environment. For example, this example of the formula, you can use the quantifier, universal quantifier. It's so we can prove the sum statement over the arbitrary number of agents. So, of course, we can we can prove the safety and liveness properties, and in general, this is the resolving of the reachability problem. Is this property reachable or not? If reachable, then we can provide this scenario or behavior in the scope of the given the formalization. So also in token economy, we can analyze that the system is inadmissible even. For example, if you consider the token price should be in the interval that we like to be for successful project. So we can check the persistence of the project under undesirable or malicious action or undesirable change in of external environment. For example, the author of the project, he can assume that there are some there are some dependency token with the cryptocurrency rate, and we can analyze and consider the project due to his assumption, or consider he assumed some malicious actions of the stakeholders, and he can also analyze to track the behavior of the system. Also, we can use the property that he assumes that projects shall be steady and stable. So what we do, how we can prove, there are some possibility. It is the resolving behavior equation. For example, we can define the sum pattern of the malicious actions. For example, this is the double spending, and to find is it possible, how is it possible in the behavior, and in what case, in which environment. We can also use the symbolic modeling of the behavior of agents. And of course, the algebra, it's not the universal tool for resolving of all problems, so we can face with the exponential explosion. So we use all the power of the model checking, and in this system also I realized some other alternative method for symbolic model, generation and invariant, different approximation method, and backward symbolic modeling. So it is implied in the platform Garuda IE AI. So you can create your own project, create your own actions. You can launch this project, obtain some charts, and to prove and check this property, create difference agent. So the future work, we also would like to move this technology for modeling of the smart contract. This a little bit complicated than to token economy, and so now we try to create the model of some smart contract, and our future work to translate it to Solidity and to map the result on the Solidity. And the other one is the proving of consensus properties, and we have an experience already with the proving of Prometheus consensus protocol. We found 8 violations and it entailed redesign. Now we work with Ouroboros. It's Cardano consensus algorithm. It's our future work. We will continue. So you can access it's a free platform. You can see the demo tokenomic and try to use for analysis of your own tokenomic. And thank you, and contact me if you have interest in our site. Thank you.
Thank you very much. Questions? So how difficult is it to put, for example, Cardano consensus protocol into the model to validate the properties? How much effort that requires?
Okay, the biggest effort is to understanding the protocol. Mm-hmm. I can do it during 1 or 2 days to formalize, but to understand it much harder, to create some high-level design. What kind of construct I would like to use in this from the system. So how to simulate this and to prove the property, it's very complicated, and it depends on the property. For example, in the experience of the Prometheus protocol, for example, we didn't prove the finality, for example, but we find the violation. So we don't know. It depends also, but it's interesting that it's suitable for proving of the statement for arbitrary number of nodes. The main feature that we can use the quantifier and to prove the statement. It's of course not all are proved good, but some classes can be recognized.
Okay. Thank you very much. Okay, let's thank the speaker again. And I invite the final speaker for the morning session. And